In this video, we'll go over the Lewis structures of some common molecules and ions. First, we'll go over OF2. So the key here is to figure out how many valence electrons total that you have to surround the molecule. So valence electrons are outer molecules or outer. So valence electrons are outer electrons that are going to participate in bonding. Okay, these are all covalent compounds, so they're going to be single bond, double bonds, or triple bonds. So OF2 is our first one on this list. So let's go ahead and do that. The first thing you want to figure out is what is oxygen happy at and what is fluorine happy at. So oxygen is happy at 6. Okay, it's in it's in group 6 of the periodic table. Fluorine is in group 7 of the periodic table, and it's happy at 7, but there's 2 molecules of fluorine. Fluorine is in group 7A of the periodic table, and group 7A, or the halogens, are happy at 7. We have 2 atoms of fluorine there, so 7 times 2 is 14. So our goal here is to get 20 valence electrons around the OF2 molecule. So to figure out our central atom, it's going to be pretty easily determined to be oxygen, because we don't know which one of the fluorines, either fluorine 1 or fluorine 2, we don't know which one will be center or central. So oxygen is our best bet for it to be the center atom. That would be its role here in this example. So we would have an oxygen. Notice there's no charge here, so we would do a fluorine and a fluorine here, single bond. Halogens like to have, such as fluorine, like to have 3 lone pairs. They're usually outer atoms. So we'll put in our outer 3 lone pair electrons for the outer fluorine atoms. The reason why I did it like this is because of formal charge considerations. 1, 2, 3, 4, 5, 6, 7. Fluorine is happy at 7. 7 minus 7 is 0. So this has a formal charge of 0. That will have a formal charge of 0. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then this will be 17, 18, 19, 20. So just to verify, we have 20 valence electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's do the formal charge for this oxygen here. 1, 2, 3, 4, 5, 6. Oxygen is happy at 6. 6 minus 6 is 0. Octet rule is satisfied also for this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So this is the best Lewis structure for oxygen atom for the OF2 molecule. And it's 2 bonds, 2 lone pairs. We'll find out that it's actually an sp3 hybridized oxygen. The next one on our list is N2F2. So N is happy at 5. We have 2 of them, so total of 10 valence electrons. Fluorine, as all the halogens are, group 7 or 7A, is happy at 7. We got 2 of those, so 7 times 2 is 14. Our goal is to get 24 outer valence electrons around the N2F2 molecule. This is pretty easy if you think about it. Halogens like to be single bonded, and they're usually outer. So let's put our 3 lone pairs. This is a common theme with halogens. They're usually, not all the time, but if they're not the central atom, they're going to be outside with 3 lone pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we still need several more electrons, actually 6 electrons. The way I see this, and this may take some time for some of you to see it, nitrogen is happy at 5, so I can do this: 1, 2, 3, 4, and 5. And looking at this nitrogen here, we got the shared one, the common bond: 1, 2, 3, 4, 5. And I think this way my formal charge for the entire molecule will be 0. The octet rule will be satisfied. Let's just do it for the fluorine here, realizing it's the same as that fluorine. 1, 2, 3, 4, 5, 6, 7, 8. Formal charge is going to be 0. Let's look at this nitrogen here, the formal charge. 1, 2, 3, 4, 5. Nitrogen is happy at 5. 5 minus 5 is 0. The octet rule for this nitrogen: 1, 2, 3, 4, 5, 6, 7, 8. So this nitrogen and that nitrogen are pretty much the same. This is the best Lewis structure for N2F2. Our next one along this list is Si2H6. And looking at the periodic table, silicon is just right in the same group as carbon. So silicon, because it's right below carbon in the periodic table, has a octet, or has a valence electron set of 4. So silicon is happy at 4. We've got 2 of those here. So 4 times 2 is 8. Hydrogen is happy at 1. We've got 6 of those. So 8 plus 6 is 14. Our goal is to get 14 valence electrons around the Si2H6 molecule. Immediately, silicon, carbon, they love 4. So this to me is very straightforward, and again, for you it may take some practice. Because it likes 4, it's going to be 1 hydrogen, 2 hydrogen, 3 hydrogen. It's not going to bind to another hydrogen here, but it's going to bind to another silicon instead. And that silicon, because similar to carbon, loves 4, it will have 4 bonds around it. And that would be the correct structure of whatever the name of this molecule here, Si2H6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They are my 14 valence electrons. Octet rule for hydrogen is 2, 1, 2, and then formal charge for the hydrogen is 0, because hydrogen happy at 1, 1 minus 1 is 0. Right, our last one here is this molecule here, CH2Cl, COO minus. So a lot of moving parts here, a lot of different molecules, a lot of different atoms that we have to somehow join together. So CH2Cl, COO minus, carbon loves 4. CH2Cl, COO minus, carbon loves 4, and don't forget, oxygen with a minus formal charge usually comes in this incarnation where it's single bonded, right? So 1, 2, 3, 4, 5, 6, 7, oxygen happy at 6, 6 minus 7 is minus 1. So and carbon loving 4, the single bonded to oxygen will have a minus formal charge. So I'm going to do this carbon and this carbon as one bond. Okay, the H2 I'll bond it to the carbon. This Cl I'll bond it to the carbon. And now I got this carbon here. That carbon was this carbon, and it formed a bond with this carbon bound to the 2 oxygens. Well, the single bond oxygen is going to be a negative formal charge. Yet carbon, which absolutely mandatory requires 4, I'm going to put the double bond oxygen there. So without having to struggle so much, by the way, this chlorine will have 3 lone pairs in that outer substituent atom. So without struggling so much, you can get the Lewis structure of multiple atoms. A little bit more complicated because this is sort of a chain, the chain of 2 carbons. It's kind of like above here where we have a chain of 2 silicon atoms and a chain of 2 nitrogens as well.